Last time we worked in section 2.6, related rates, and we had gotten to the final example, number 3, about an oil tanker. And let's just kind of remind ourselves where we were in terms of the picture and the details that we already have written down. Oil spills out of a tanker at a rate of 90 gallons per minute. The oil spreads out in a circle, but the circle has thickness 1/8 inch. Determine the rate at which the radius of the spill is increasing when the radius reaches 100 feet. So we'd written down that we had the volume that was changing at a rate of 90 gallons per minute. But we needed to change that gallons into something that relates these quantities together. And we looked and we said, okay, there's feet, there's inches, and we turned it into the feet. We turned everything into feet. So you had the ratio that I gave you that was 1 cubic foot was equal to 7.5 gallons. That was a given amount. It wasn't in the problem, I just had to give it to you. It's one thing that you could look up if you had to look it up or something like that on a particular problem, but I found that one for us. And we found out that that was actually the same as 12 cubic feet per minute. We have our picture of a circle with thickness, which is actually something called a cylinder. And we had written down that our height was in 1/8 of an inch. It's a constant, but turning that into feet, it was 1/96 feet. I don't know why I have inches written down there. Let's fix that. No inches there, just feet. So 1/96 feet was actually our thickness of our cylinder. And we want to know, or we know that at some point in time, there is going to be a 100-foot radius, right? And then we're supposed to be finding dr dt. All right, so where we are right now is we're at the point where we need to figure out what relates all these quantities together. So what equation, maybe not specifically equation, but what are we looking for the equation for in this picture to relate all these? What's that? That's the quantity we're going to find, but what's the equation that's going to relate everything? The what for the cylinder? The volume for the cylinder. We need a formula for the volume of a cylinder. May or may not remember that one. Does anybody happen to remember what the formula is for the volume of a cylinder? Very good. Yeah, it's the area of a circle times the height, which is pi r squared h. So we have the volume, which is pi r squared, that's the area of a circle, times the height, h. And we're going to use this equation because it relates the quantities together to find the relationship or the relation between the rates. So we're going to do implicit differentiation. We talked about last time, this is with respect to time, because these quantities are all changing with respect to time, not with really respect to each other, right? The variable that's changing is time. So if I take the derivative of volume, that's dv dt. Now over here on the right, take a look. I've got two variables, r squared and h. Are they both really variables? Okay, Nate, you shook your head pretty quickly that you don't think so. Which one do you think is not a variable?
Height.
The height. He's right. Does anybody know why the height's not a variable? Yeah, constant 1/8 inch, right? I mean, it's liquid. This is oil and it's liquid. It can only sort of stack up so high, right? So that's what's going on. So this is really not a variable. The only variable in the problem is the r squared. So if you want, you could actually erase this from the get-go and actually put in the 1/8 inch, 1/96, wasn't it? Feet, because we put it in feet. So if it helps you to see it in there right now, that's a good idea to put it there. So I only have to do the derivative of the r squared. The pi is going to stay. The 96 on the denominator is going to stay. What's the derivative of r squared? 2r, and then what? dr dt, because that rate is changing with respect to time. All right, so this is now pi over 48 r dr dt. Okay, so that's cleaned up version, if you will. And now we have some values that we can put in. What can I put in and where? The 90, but it isn't 90 anymore. We changed it to 12. Yeah, so we're going to put the 12 in where? The dv dt. It's 12 cubic feet. What was it? Per minute. So this one's 12. I already have a pi and a 48, pi over 48. What else can I put in? Yeah, the 100 for r. And dr/dt I don't have. That's what I'm looking for. Right? So we have 12. Well, we'll draw it this way. Equals, let's see, 100 over 48 would be 50 over 24 divided by 4. How about 4? 25 over 12, 25 pi over 12. You don't have to actually do that conversion, but I think that's right. dr/dt. Our goal here is to take this quantity and to solve it for dr/dt. So what am I going to have to do? What's my last step? Divide or multiply by the reciprocal, right? So I'm going to take the 12 and I'm going to multiply by the reciprocal, which is 12 over 25 pi. This is going to equal the dr/dt. Okay, so 12 times 12 is 144. Grab your calculator. We actually want the decimal representation. Please be careful in the denominator that the 25 and the pi are inside of a set of parentheses together. If you just type in 144, the division sign, and then 25 pi, it's going to divide by 25 and then multiply by pi because it works from left to right. Okay? So make sure you put the entire denominator in parentheses. So it should look something like this when you key it in. And your calculator may actually allow you to do it a little bit differently depending on the mode that you have set up, if you're in math type or not. But some of you actually are not, I know, because of the versions the calculator you have, so make sure you put the division of 25 pi like that. So it doesn't actually say in our problem, right? So what I've been saying is 2 decimal places unless otherwise indicated. So let's go with 2. Did you get a value for us, Josh? 1.83. Do you guys have that? Okay, 1.83 what? Okay, so the radius units, which we have changed everything into feet, right? Over the time units, which are minutes on this problem, right? So this is 1.83 feet per minute that the radius is changing. So about 2 foot, right? Is it slow? I don't even know. That sounds fast to me, like in a minute. Yeah, but that feels like a lot to me. All right.